All right, let's dive right in. Today, we're going on a journey to the absolute edge of reality to tackle one of the biggest questions in all of science. What is actually going on inside a black hole?
I mean, that's a pretty powerful way to put it, right? And we're not talking about some fantasy creature. This is a real cosmic monster. And trust me, what it can do is way, way stranger than you could possibly imagine.
Okay, so before we plunge into one of these things, we kind of need a mission briefing, right? We need to know what we're up against. So let's get the basics down first.
So here's the simplest way to think about it. A black hole isn't empty space, quite the opposite. It's a huge amount of stuff, a ton of matter just crammed into a space so unbelievably tiny that its gravity just takes over. It becomes the most powerful force around. And once you get too close, yeah, there's no pulling away. Nothing can escape. Not even light, and that's the fastest thing there is.
Okay, so you really need to get two key parts of a black hole. First, at the very, very center, you have this singularity. That's the destination, right? It's this point that is infinitely tiny and infinitely dense, where all the matter gets crushed and, well, where our understanding of physics just completely falls apart. Then you have the event horizon. Think of this as the ultimate border, the point of no return. The second you cross that line, gravity's grip is so intense that not even light speed is fast enough to get you out. You're in, and there is absolutely no turning back.
So hang on a second. If these things suck in all light, making them completely invisible, how in the world did we ever find them in the first place? I mean, trying to find something that's literally invisible sounds impossible, right? Well, it's one of the greatest detective stories in the history of science.
And this was not an overnight discovery, not by a long shot. The whole idea started way, way back in 1783 with his concept of a dark star. Just an idea. Then, more than 100 years later, Einstein's mind-blowing theory of general relativity basically said, hey, these things should actually exist. But it was all just theory until the 1970s. That's when astronomers saw a star doing this weird wobble, like it was being tugged on by something they couldn't see. And that something was Cygnus X1, the first confirmed black hole.
Finding that first one, though, that was like opening a floodgate. Because it turns out, not all black holes are the same, not even close. It's like we've discovered this entire cosmic zoo of them, and they come in all sorts of sizes, from, kind of small to, well, sizes that are just completely mind-melting. So let's break down the two main types you'll find out there. On one hand, you've got your stellar mass black holes. These are the leftovers from a single massive star that goes supernova, a pretty violent birth. Then you have the supermassive black holes. These are the absolute titans, the monsters that hang out in the center of most big galaxies. Yep, even our own Milky Way has one. We're still not totally sure how they get so huge, but their sheer scale is just staggering.
And when I say staggering, I am not kidding. Just to try and wrap your head around it, look at this number, 66 billion. That's the mass of the biggest black hole we've found so far, TON 618. And that's not 66 billion pounds or tons, that's 66 billion suns. 66 billion times the mass of our entire sun packed into one object. It's a number so big your brain can barely process it, but it's out there. It's real.
Okay, deep breath. We know what they are, we know they exist, and we know how terrifyingly big they can be. So now, it's time for the main event. Let's run the ultimate thought experiment. What would really happen if you fell into one?
I mean, come on. This is the question, right? It's what sci-fi writers and actual scientists have been obsessed with for decades. And the cool thing is, thanks to the laws of physics, we don't really have to guess. We can paint a pretty clear, and I gotta warn you, a pretty gruesome picture of that final trip.
Yeah, scientists have this fantastic, if a little disturbing, name for what happens. They call it spaghettification. Get the picture? As you fall in, feet first, the pull of gravity on your feet is way, way stronger than it is on your head. So what happens? You start to stretch, and you keep stretching and stretching until you're literally pulled apart into a long, thin noodle of individual atoms. It's a pretty grim way to go, but hey, it's scientifically accurate.
And just when you think it can't get any weirder, it does. This is where Einstein's relativity comes in and just messes with your head. See, from your perspective, your spaghettification and plunge into darkness is quick and, fatal. But for your friend watching from a spaceship a safe distance away, they see something totally different. Because that intense gravity is also warping time itself, to them, you would seem to slow down. You get redder and dimmer, and you just freeze right at the edge of the event horizon, looking like you're stuck there forever. Same event, two completely different realities. Wild, right?
So, let's recap. You've crossed the point of no return. You've been turned into atomic spaghetti. An outside observer thinks you're frozen in time forever. But what happens next for you? What's actually waiting at the end of that journey, at the singularity itself? This is the point right here where we basically walk off the edge of the map of known science.
And that brings us right back to the question we started with. After all of this, after all the mind-bending physics and astronomy, what is actually inside a black hole? What is the singularity?
Well, here's the thing. There isn't one simple answer. We've got theories, of course, and each one is crazier than the last. You know, maybe it's a place where our physics just stops working and a whole new set of quantum rules takes over. Or could it be a gateway, a portal to another universe? Some physicists think all the information that falls in is stored there forever, like a cosmic hard drive. Others think it's the ultimate incinerator, where information is just gone.
Which brings us to the most honest answer. And honestly, maybe the most exciting answer of all. The simple truth is, we don't know. All the math, all the science that lets us describe our entire universe, from an apple falling from a tree to the most distant galaxy, it just breaks. It stops working at the singularity. Our instruction manual for the cosmos just runs out of pages.
So let's leave you with this final thought. A black hole isn't just a destructive monster, it's a clue. It's a giant cosmic signpost pointing directly at the edge of what we know, screaming at us that there are new laws of physics out there waiting to be discovered. So what's inside a black hole? The answer to that question might just be the key to the next great leap in understanding, well, everything.